We'll do some more examples of this, so of continuous distributions. So question is, a package with a label 100 gram containing substance with a uniform distribution between 96 and 104 grams. What is the probability that weight is less than 99 grams? So for all these you have to just draw the uh, distribution graph, and you see that this is 96 and this is 104. This height is the fx, and we want to know the distribution that it is less than 99. So first thing we have to do is to calculate the fx. So length times height needs to be 1, and length is 104 minus 96, and then the height, and the height is the fx, so that is 1. So fx is equal to 1 upon 8. So once you know the fx, now all we have to do is to do the integrate between the limits of 96 and 99 fx dx, and fx is 1 by 8. So all we have to do is integrate between 96 and 99 1 by 8 dx. That will give you 0.375 or 37.5%. Next question is, amount of time a person has to wait for train is uniformly distributed between 0 to 40 minutes. Determine fx. Again we're gonna draw this, we're gonna do this, we're gonna say this is 0, well, and this is 40, and we're gonna say 0 to 40, or 40 times height is equal to 1. Height is going to be 1 by 40, and we know that height is equal to fx, so that's the fx. The next question is in the same one, what is probability that a person has to wait less than 8 minutes? So now in this one we will see that, okay, this is the area that we want to see. So to find that area, we're going to go back to our we already know the fx, so all we have to do is to do 0 to 8 1 by 40 dx. That will give you 1 by 5. You can also not use the calculus and just calculate, because now you know the height is 1 by 40 and this thing is 8, so you can also calculate it 8 times 1 by 40 or 1 by 5, because all you need is an area of this small rectangle. Now another question is, what is the probability that person will wait more than 30 minutes? Again, now we can do this with a integration of 30 and 40. This is going to be 1 by 40 dx, and that will give me an answer of 1 by 4. Now we can keep making this more and more complex. Now we're gonna ask that probability that x is more than 10 but less than 26. Okay, so, and we also want to calculate probability of x is exactly equal to 20 and probability of x is more than 45. Now we can see from this graph that x of more than 25 is going to be 0. Okay, but when we want to calculate the x of 20 itself, so now we have this diagram where it is 0 and 40, and this is 1 by 40, and we want to know the area of this point itself, 20. So it has to be 0, because if it is 1 point, there is only one value that it will be 0. It is always has to be a range. So if it is this, then in 26, then you can see that right now we have all you have to do is 16 times 140. That will give you the answer. Or you can also integrate between 10 and 26 140 dx. That will give you the answer. Now then there is this thing, what is the mean and standard deviation? What is the mean time they're gonna have to wait for uniform distribution? The mu is a plus b upon 2, so that is going to be 20. So that is the mean value for uniform distribution. And what is the standard deviation? Standard deviation is going to be b minus a upon under root 12. So that's the standard deviation of the uniform distribution. So that is the mean value, and this is the formula for the standard deviation of the uniform distribution. Okay, now another question is, what is the 85th percentile? What is the 85th percentile of the weighting? So what is the 80th percentile of the waiting time? So how do we do that? So we have to divide this graph. So it starts with 0 and it's up to 40, right? So there will be this middle thing which is 20, which would be 50th percentile, and then there would be thing here which will be 75th percentile, which would be 75th percentile, which would be 30, and there would be this little line here which would be which is the k, which we don't know, and this is going to be the 85th percentile. So how do we k is the value corresponding to the 85th percentile. So, and what number are we interested in? We are basically interested in all this area which is towards the left of the 85th percentile, which will give you the waiting period for that, and that will be calculated basically just by base into height, and the base is 85th. We know that it's 85, and the height is, so k minus 0 is what we want to know, times 1 by 40 is equal to 0.85. So k minus 0 is 0.85 into 40. This just becomes, so minus 0 just goes here and becomes plus 0, so it doesn't really matter. So 0.85 on 40 is 34. So 34 is the number that is reflective of the 85th percentile.